Today, we're diving into one of the boldest, most controversial claims in modern science. It's a theory that claims to solve the biggest mysteries in the universe, and it was developed for over 30 years in complete isolation by a former dentist who says he's finished the work of Albert Einstein. You know, for the last part of his life, Einstein was obsessed with one single epic goal, a theory of everything. He dreamed of one beautiful, simple equation that would finally unite the world of stars and galaxies with the bizarre quantum world of tiny particles. It was his ultimate quest, and he died without ever finding it. And here's where the story takes a wild turn. Because a total outsider to the world of physics, a man named 양동봉, is now claiming that he did it. He says he's picked up right where Einstein left off and has actually found the key to it all. Now, to really understand just how massive this claim is, we've got to start with the huge crack that runs right down the middle of modern physics. It's a conflict between two theories that are both somehow incredibly successful, and yet they absolutely cannot stand each other. Steve, on one side, you have general relativity. It's beautiful. It describes the big stuff, gravity, planets, galaxies, with almost perfect accuracy. Then, on the other side, you have quantum mechanics, which is the rule book for the tiny world of particles and forces. Both of them work flawlessly in their own backyard. But the moment you try to use them together, like to figure out what's going on inside a black hole, the whole thing it breaks. The math falls apart. For 100 years, finding a bridge between these two worlds has been the absolute holy grail of physics. So if that's the problem that has stumped the world's greatest physicists for a century, who exactly is the person claiming he finally solved it? Well, he's not from a fancy university like Princeton or Cambridge. He's Dr. 양동봉. Get this, at 39 years old, while he was still a practicing dentist, Dr. Yang started on this incredible 34-year solitary mission to teach himself theoretical physics. And this wasn't just some weekend hobby. It was a relentless, all-in obsession, done completely on his own, totally outside the official world of science. And what drove him wasn't the dream of winning awards or getting famous. His supporters say it all started with one incredibly powerful question. Why do 1 billion people starve? He truly believed that science's real job wasn't just to build cool technology, but to end human suffering. And for him, a complete theory of the universe was the only way to get there. So, what is this theory really? Well, let's dive in because at its heart are a few core ideas that are frankly pretty radical. The first big idea is something called the zero zone. The theory basically throws out our old definition of a point. It says a point isn't infinitely small, it's not nothing. Instead, it's a real, actual, finite space, super tiny, but real, that holds the potential for both the infinitely big and the infinitely small at the same time. It's not just emptiness, it's a point of perfect balance holding everything. Now, this completely changes how we think about the Big Bang. See, the standard theory says our universe exploded from a singularity, a point of infinite density, where our laws of physics just stop working. The zero-zone theory claims to get rid of that problem. It says there was no singularity. Instead of a one-time Big Bang, the universe began with a big bounce from a finite zero zone, and it's been in an endless cycle of contracting and expanding ever since. The second key idea is a principle called 일승비업, which translates to something like the one multiplication rule. The idea is that all the crazy complexity we see in the universe, from the smallest particles to giant galaxies, even to us, all of it comes from one single, simple underlying rule. Think about it like a symphony orchestra. You've got all these different instruments, but they're all following one conductor to create one single beautiful piece of music. Okay, and this is where a very famous number in physics pops up, 137. This number is basically the inverse of something called the fine structure constant, and it dictates how strong electricity and magnetism are. The brilliant physicist Richard Feynman once called it a magic number and said it was one of the greatest damn mysteries of physics that nobody could explain. Well, the zero-zone theory looks at 137 and calls it a welcome message from the universe. Why? Because it argues that if this number were just a tiny bit different, atoms wouldn't hold together, stars could never light up, and life as we know it would be totally impossible. It's presented as the ultimate proof that our universe is perfectly fine-tuned for us to exist. So this is the really crucial part.
What does any of this mean in the real world? This isn't just an abstract idea. The theory's supporters claim it could unlock some truly world-changing technologies.
And the claims are just extraordinary. First, they talk about a virtual accelerator, basically a computer program that could simulate particle physics, which would mean we wouldn't need these giant multi-billion-dollar colliders anymore. Second, a mind equation, a mathematical formula that actually connects our mind to our body, which could revolutionize mental health care. And third, and this is the biggest one of all, a way to produce limitless, safe, zero energy. In theory, this could end scarcity, hunger, and resource wars forever, the very problem that started this whole journey. As you can probably guess, making claims that big has been met with a lot of skepticism. It has sparked a really fierce debate, with the theory's supporters on one side and the entire mainstream scientific community on the other. On one side, you have groups like the Korean Physical Society, and they've been pretty blunt, saying the theory has no scientific value. They point out that it hasn't been published in any major peer-reviewed scientific journals. But on the other side, the theory's supporters say it hasn't been given a fair shot. They argue that the traditional system just isn't set up to evaluate something so different, and they're asking for open, public verification. And you know what's also fanning the flames of the skepticism is the way the theory's been promoted. When you use phrases like Nobel Prize contender or say you've surpassed Einstein, those are huge red flags in the scientific community. Science values quiet, careful, evidence-based work, so that kind of talk has just made it even harder for them to get a serious look from the experts. So where does all this leave us? Is this a revolutionary breakthrough or just a dead end? The path forward for this theory is just as unconventional as the theory itself. Right, so instead of trying to get published in journals, the plan is to take their case directly to the public. We're talking about proposing live, maybe even televised demonstrations, and issuing public challenges for anyone to come and check the math for themselves. They're trying to bypass the whole system with what they call shocking proof. And this really leaves us with a huge question. I mean, history is full of stories about groundbreaking ideas that came from outsiders and were fiercely rejected at first. But for every Galileo, there are thousands of other theories that were just wrong. So what is the real test of an idea? Is it the approval of experts and the careful process of peer review? Or is it a result that can be proven to work, no matter who it comes from or how strange it might sound? The final chapter on the zero zone theory has yet to be written.